Alright, so section 1.4 is on solving absolute value equations. Okay, so we've done some basic things with regular equations, but what happens if we have absolute values? So the absolute value of the number x, written with the little lines on each side, right, the absolute value of x, is the distance from x to 0 on a number line. So because it represents a distance, it's always going to be the positive version of the number. So the absolute value of a number is always positive. So if we talk about the absolute value of -5, its distance to 0, right, is a total of 5 units. Okay, that's what absolute value means. So it says, note, when solving absolute value equations, you always have to isolate. So I underlined, I capitalized, and I bolded. Probably important, right? So you must isolate the absolute value first. You will then you'll have two equations that you're solving. So for example, if you have x plus 3 is equal to 5, then the two equations that you would solve are going to be x plus 3 could be 5, or x plus 3 could be -5. So let's think about that. All right, what we're saying is when we take the absolute value of whatever's inside here, we get an output of 5. Okay, so if we're taking the absolute value of something and we're getting 5, doesn't it make sense that those two things would be 5 or -5? Okay, that's where the equation's coming from. So it says, however, if the absolute value is set to a negative number, so if instead I had said something like x plus 3 in absolute value is equal to -5, can that ever happen? No, you can't take the absolute value of something and get a negative number out. So when that happens, we write no solution, or we do the little symbol, which means no solution, the null set. Okay, so you must write no solution in that case, or the symbol, this. That's why it drives me crazy when people write their zeros like the null set. It's like, that's not 0, that's no answer. All right, so number 1, see how the absolute value portion is already isolated. It's already by itself. Okay, so that means that we can break it into the two equations. So inside this absolute value, if I'm taking the absolute value and getting 10, that means that inside part could be 10 or -10. So we're going to say -3 plus x could equal 10, and -3 plus x could equal -10. And we solve both of those equations. So when I add 3 to the other side, I get x equals 13. When I add 3 to the other side, I get -10 plus 3 is -7. And both of those work. You can plug them back in. You'll see that you get the absolute value of 10 and -10, which both give you 10. All right, now this next one, it is not isolated. Do you guys see the difference? The absolute value is not by itself. So kind of treat it like a variable and just, just like you're solving an equation, get the plus 6. So add the 6 to the other side. So do that first. And then we divide by 2. So we get x plus 4 and absolute value is equal to 2. So we isolated the absolute value first. So now that it's isolated, you can break it into those two equations. So the first equation is going to be x over 4 is equal to +2. And the second equation is x over 4 equals -2. So when we're breaking into the two equations, we don't have absolute values anymore. Okay, so we end up getting x is equal to 8 and x is equal to -8. So every year that I teach absolute values, people will get answers like this, 8 and -8, and then they assume that every single answer is going to be like the positive and negative version of the number. Did that happen in number 1? Did I have 13 and -13? Yeah, so it doesn't necessarily happen. Can anybody give me a good reason? What are the ones where they're going to be like 8 and -8, or the ones where they're going to be different? What made it different in number 1? Can you guys tell? Yeah, Becca. No, those are odd numbers. Yeah.
There was a fraction of the second one, so that means you had to multiply.
Yeah, there was a fraction, but that wasn't really why it was. It had to do with like the -3 with the x. Okay, so when there's like an x plus 3, x minus 3, or whatever, that's when they're not going to be the same number. But the other one just had like x over 4. It didn't have like a plus or minus inside the absolute value. So that's when they're actually going to be opposite each other. Okay, so let's try some more. So again, we have our absolute value isolated on this one, so it's ready to break apart. So we break it apart into our two equations. So I'm going to have -4y plus 2 is equal to 10. And I have -4y plus 2 is equal to -10. All right, so I'm going to subtract the 2 over, so I get 8. So -4y equals 8. Divide by -4, I get y equals -2. I'm going to subtract the 2 over, I get negative 12. So negative 4y equals negative 12. I'm going to divide by negative 4, I get y equals 3. Both of those are your answers. All right, so number 4, we have to isolate. We're going to multiply the 3 over first. So I get 2p plus 7 in absolute values is equal to 3. Now we're ready to break into the two equations. So I have 2p plus 7 equals positive 3, and I have 2p plus 7 equals negative 3. So notice how nothing is changing like on the left side of the equation, right? It's just still 2p plus 7. Some people get confused, like on number 3 we had negative 4y plus 2. Some people make it positive because they see an absolute value and they're like, oh, it has to be positive. So don't do that. The left side stays exactly the same, just drop the absolute values. All right, so I'm going to subtract the 7 over, so I get negative 4. And I divide by 2, so I get negative 2. I'm going to subtract the 7 over, so I get negative 10. I divide by 2, so I get p equals negative 5. Both of those are your answers. Okay, and you can always check. You can go back in. It will work out. All right, so this next one's a little bit different. So what happens? So I add 3 to both sides. Yeah, it cancels it out. So the absolute value is equal to 0. Okay, the absolute value can be equal to 0. It just can't be equal to a negative number. Okay, but do I really need to break it into two equations? No, because really like 0 and negative 0, that's still just 0, right? So we can just say 0.5x is equal to 0. So when I divide by 0.5, I get x is equal to 0 still. All right, the next one, I'm going to add the 2 over. So I have negative 1/2 times the absolute value of p minus 2 is equal to 5. I'm still trying to isolate that absolute value, so what's my next step? Yeah, multiply by the reciprocal, multiply by negative 2. So when I do that, I get absolute value of p minus 2 equals negative 10. Logan, what do you think? Absolute value equals negative 10. Hey, you guys aren't Logan.
Yeah, it can't equal negative 10.
Yeah, you can't take the absolute value and get a negative number, right? Does that make sense? So we can't have a solution to this. So this is a no solution. So think about it. I mean, even if you plug in like 12, right? 12 minus 2 is 10, absolute value. You're never going to get a negative 10. You take the absolute value, it's going to be the positive version of the number. Or like negative 10 or negative 8 minus 2. That's negative 10, but in absolute values, it's positive 10. So no solution. So always look for those because a lot of people just kind of get used to like doing the steps and they're like, okay, I'm going to isolate, I'm going to break it into 2, I'm going to solve, and then they forget, oh wait, I have to think about that. I can't just put my answer. All right, so I'm going to subtract 17. So I get a negative. Absolute value of 3x plus 1 all over 4 is equal to negative 7. We can multiply the 4 over and we get negative 28, but we still have that negative in front of the absolute value. So what we're doing is we're dividing by negative 1, or multiplying by negative 1, it doesn't really matter. So we get the absolute value of 3x plus 1 is equal to positive 28. Because this negative out front is like a negative 1, right? It's like a number.
So why would you multiply by negative 4?
You could, like all in one step, yeah. If you noticed it was like negative 1/4, you could multiply by negative 4 on both sides. I just broke it up. Negative 28 times, no wait, negative 7 times negative 4 would be positive 28. All right, so we've isolated, so we break in our two equations. So we have 3x plus 1 is equal to 28, and we have 3x plus 1 is equal to negative 28. And then we solve both of these. So when I subtract the 1 over, I get 27. Divide by 3, I get 9. Subtract the 1 over, I get negative 29. And divide by 3, I get negative 29 over 3. That will happen a lot where one of them's like super nice and one of them's gross. Or they're just both gross. It's okay to have weird numbers in algebra too, right? guys feeling good about these so far? Now let's say you did go too far, like on that last one, on number 6, you went too far and you went ahead and separated and you got 2 answers. What do you think happens when you check them in the original? They don't work. So all of them so far, except for number 6, will work when you check. But since number 6 was a no solution, that's one where if you went back and checked your answers, it would not work. That's why it's good on tests to go ahead and check answers. All right, so this next one, it looks pretty messy, doesn't it? Do you think we can make it look nicer? You guys remember that trick I taught you? So let's clear the fractions. Let's multiply through by the least common denominator. So our least common denominator is 8. So we're going to multiply both sides of the equation by 8. Kind of funny it's number 8. My 8 was already there. All right, so I'm going to have 8 times 1/2 is 4. 8 times negative absolute value all over 8. Do you guys see what's going to happen? The 8s are going to cancel. I'm going to have a negative absolute value of 4x plus 5. 8 times 3/4. Any of you know that off the top of their head? 6, right? So if you think about like fractions, if you divide 8 into fourths, right? 8 would be divided into fourths, it would be 2, right? And then you have 3 of them. So 3 of the 2's will be 6. Or you can kind of think of it as 8 times 3/4, you get 24 over 4. Or you can reduce, right? There's lots of things you can do to get it in your head. All right, and then equals 1. So now it looks a lot simpler at least. So we cleared the fractions. So let's combine our like terms. I have 4 plus 6, so that's 10. So if you get confused, remember this is a plus in front of there. All right, and that's all equal to 1. Subtract the 10. So I get negative absolute value of 4x plus 5 equals negative 9. And I divide by negative 1. So I get 4x plus 5 in absolute values. What am I? Yeah, equals 9. We good? So I got rid of that negative out in front. And now we break it into the 2. So our 2 equations, since it was positive 9, we're going to have that inside part, 4x plus 5, could be 9, or it could be negative 9. And we solve each of them. So I subtract the 5, and I get 4. I divide by 4, and I get 1. I subtract the 5, I get negative 14. I divide by 4, and I get negative 14 over 4, which reduces negative 7 over 2. Yep, so those are our 2 answers. Okay, that's as hard as I get. Can you handle that? All right. So those were equations. So let's talk about some equations where maybe it's a little bit different. So maybe we have variables on both sides of the equation. Okay, so these were all where we had just a number, right? When we isolated, it was like absolute value equals a number. These are going to be a little bit different. So it says if there's an x on the non-absolute value side, there may be only one solution that works in the original problem, or both work, or no answers work. Okay, so that means that we're going to have to check our solutions to see if it makes it true or false. Okay, so it's not really super important on the other ones, except in cases like number 6, like I talked about, where you should have caught, like right here, you should have noticed, oh wait, there's no solution on that one, right? So really it's okay if you don't check as long as you're noticing that. But these ones you definitely have to check, okay? So we're going to set it up the same way. We're going to isolate the absolute value. So number 1, is it isolated? Yeah, actually all 3 of these are isolated. That was nice of me. I should have made a messy one. All right, so I have absolute value of 8 plus y is equal to 2y minus 3. So the pattern that we did on the last ones is that we took our absolute values, we removed it, so we said 8 plus y, and we set it equal to the right-hand side, and then the opposite of the right-hand side. We made it negative, right? So what happens when I make the entire right-hand side, this 2y minus 3, what if I make it negative? Negative 2y plus 3, exactly, good Bill. Do you guys get it? So that's what we're going to do. We're just going to make the whole thing negative. So you can put a negative and do parentheses, or if you just want to do it in your head and say, oh wait, it's going to be negative 2y plus 3, that's totally fine as well. And then we just solve both equations. So be active note takers, kind of solve it along with me, see what you get for each one. Okay, did you get 11 and negative 5/3? All right, now the 11 is going to be super simple to check. When I plug in 11, I get, can I do what?
Can you pause for a moment?
Yeah. All right, so kind of check your answers, see if they work. Usually if I'm checking answers to see if they work, I put a little question mark over the equation, the equal sign. So for the first one, when I plug in 11, I have 8 plus 11 is 19. And when I take the absolute value, don't you get 19 still? Yeah, so that's 19. And then 22 minus 3 is going to be 19. So that one works. So 11 is definitely one of our answers. The fraction one is a little bit harder to check. These ones are not so fun. All right, so for the fraction one, I have 8 minus 5/3 equals 2 times negative 5/3 minus 3. And I'm putting a little question mark over because I'm not sure if it's true or false. Now you can do all the work with your fractions, or you can be smarter than the system. Does someone know right away whether this one's going to work or not? Don't just assume it's not. Yeah?
Because the right side is all negative, so it's going to be negative number.
Yeah.
Absolute values cannot be negative.
Do you guys see what Karen's saying? She's saying that when she does 2 times negative 5/3, that's a negative number still. And then when you subtract 3 from that, it's even more negative. Does that make sense? But the left side was in absolute values. So this is going to be a positive number equaling a negative number. That can't happen. Okay, so that one does not work then because of that. So we cross that one out. So sometimes you can make it easy on yourself and not like deal with all the fractions. You can just think, oh wait, is this going to be positive or negative? All right, so let's try the next one. So I'm going to take my 3x plus 2, and it's going to equal 4x plus 5. That's the first equation. And then I'm going to take 3x plus 2, and it's going to equal the opposite of 4x plus 5. So if you want to do a negative out front, it's going to be negative 4x minus 5. Okay, so we're going to solve both of the equations. So when I subtract 3x over, I get x. When I subtract the 5 over, I get negative 3. When I add my 4x over, I get 7x. When I subtract my 2 over, I get negative 7. So I get x equals negative 1. So no fractions this time at least. So can you tell that one of these does not work right away?
Yeah.
Which one?
The one that we just did because,
I don't know. Negative 1? I think negative 1 might work. Logan, what do you think?
Negative 3 can't work because on the right side, that would be negative.
Yeah, if you plug in a negative 3 right there for x, don't you get negative 12? And negative 12 plus 5 is going to be a negative 7, right? So the right side is negative. So if you're checking, you end up getting negative 3 times 3 is negative 9 plus 2. And we're seeing if that's equal to negative 12 plus 5. You end up getting negative 7 equals positive 7. Okay, that doesn't work, right? Because the one side was in absolute values. It had to be that positive version. So this one is out. We cross it out. It does not work. All right, but when we try negative 1, let's see if that one works. If I try negative 1, I have negative 3 plus 2 in absolute values. I'm seeing if that's equal to negative 4 plus 5. So I get 1 on the right side. I get negative 1, but it's in absolute values. So I get 1 on the right side. That does work, right? So negative 1 is working. All right, do you want a second to try number 3? Do you want to try it on your own? All right, so I'm seeing a lot of fractions as I'm walking around. You guys have a fraction? All right, so we have 7x plus 6 is equal to 6x minus 9. And we have 7x plus 6 is equal to negative 6x plus 9, right? I distributed the negative n. So I did negative and then times 6x minus 9. So I get x equals, I subtract the 6 over, and I get negative 15. So as I walked around, I saw a lot of you guys cross this one out. Okay, you guys agree? If you plug in negative 15 right here, 6 times negative 15 is a negative number, and subtracting 9 makes it even more negative. So it can't possibly be equal to a negative, so that one's out. So on the next one, when I add the 6x over, I get 13x. When I subtract the 6 over, I get 3. So you should have x equals 3 over 13, and I saw that on a lot of people's papers as I went around. Now, a lot of you guys just circled it. Did you really check it? It could be. I don't know. I didn't see any check steps as I walked around. You guys just assumed it worked. Sometimes they do not work. So let's see. So 7 times 3 over 13 plus 6. We're seeing if that is equal to 6 times 3 over 13 minus 9. Did you guys know that your calculator will do fractions for you? So let's say I go to my calculator. I mean, I could do this without a calculator clearly, but we will use one with calculators. So if I put in 7 times 3 over 13 plus 6, like that, just like it is, and hit enter, I get that number. Can you guys see this? Can you guys hit the light maybe? And then if I do math 1, it takes my answer and it changes it to a fraction. So I have 99 over 13. Okay, so if I try the other side, I want to see if I get 99 over 13. So if I do 6 times 3 over 13 minus 9, oh, look, I get a negative number. So if I do math 1, I bet I get negative, look, negative 99 over 13. Was it minus 9 on the original? Oh, is it? Hang on, what did I do? Oh, no, I'm plugging it into the original, right? So plug it into the original. So that part was in absolute value, so that's why that was positive, but this one is still negative. So the 6 times 3 over 13 didn't make it big enough. And if you think about it, 6 times 3 over 13, well, 3 over 13 is definitely smaller than 1/2, right? So if I did 6 times 1/2, isn't that just 3? So this is even smaller than 3, so subtracting out 9 is making it a negative number. All right, so we have negative 99 over 13. So if we have positive 99 over 13 equals negative 99 over 13, that doesn't work, right? So this answer is also out. So our final answer for this is no solution. Don't you hate that? In math class, no solution is sometimes a solution. How rough. All right, and then the last little bit that we have to talk about, oh, we're going to do inequalities next time, actually, so that's where we end, isn't it? So we also will have absolute value inequalities, but they won't be until the next section.